Everyone feels something when they're in a really good starry place on a really good starry night and they look up and see this. Some people stick with the traditional feeling called struck by the epic beauty or blown away by the insane scale of the universe. Personally, I go with the old existential meltdown followed by acting weird for the next half an hour, but everyone feels something. Physicist Enrico Fermi felt something too. Where is everybody? On a really starry sky seems vast, but all we're looking at is at our very local neighborhood. On the best nights, we can see up to 2,500 stars, roughly 100 millionth of the stars in our galaxy. And almost all of them are less than 1,000 light years away from us, or 1% of the diameter of the Milky Way. So what we're really looking at is this. When confronted with the topic of stars and galaxies, a question that tantalized most humans is there other intelligent life out there? Let's put some numbers to it. As many stars are there in our galaxy, 100 to 400 billion. There are 10 galaxies out there. Together, it comes out to a typically quoted range between 1 to 4 septillion total stars, which means that for every grain of sand on the beach on Earth, there are 10,000 stars out there. The science world isn't in a total agreement about what percentage of the stars are sun-like, similar size, temperature, luminosity. Opinions typically range from 5% to 20%, going with the most conservative side of that 5% and the lowest end of the numbers of the total star, 1 to 4 septillion. It gives us a 50 sextillion or 5 billion trillion sun-like stars. There's also a debate over the percentage of those sun-like stars might be orbited by an Earth-like planet, one with similar temperature conditions and could have liquid water and potentially support life similar to that on Earth. Some say that it's as high as 50%, but let's go with the more conservative 22% that came out of a recent PNAS study. That suggests that there is potentially habitable planets orbiting at least 1% of the total stars in the universe. A total of 10 sextillion Earth-like planets. So there are 100 Earth-like planets for every grain of sand in the world. Think about the next time you're at the beach. Moving forward, we have no choice but to get completely speculative. Let's imagine that after billions of years in existence, 1% of Earth-like planets develop life. If that's true, every grain of sand would represent one planet with life in it. And imagine that on 1% of those planets, the life advances to an intelligent levels like it did here on Earth. That would mean there would be 1.1 quadrillion intelligent civilizations in the observable universe. Moving back to just our galaxy, doing the same math at a lowest estimate for the stars in the Milky Way, 100 billion, we'd estimate there are 1.1 billion Earth-like planets and 11 million Earth-like planets with intelligent life. SETI, Search for Extraterrestrial Intelligence, is an organization dedicated to listening signals from other intelligent life. If we're right, there are 11 million intelligent civilizations in our galaxy. Even a fraction of them sending out radio waves or laser beams or other modules attempting to contact others. Shouldn't SETI's satellite dish array pick up all kinds of signals? But it hasn't. No one ever. Where is everybody? Welcome to the Fermi paradox. It gets stranger. Our sun is relatively young in the time span of the universe. There are far older stars with far older Earth-like planets, which in theory should mean civilizations far more advanced than our own. As an example, let's compare our 4.54 billion old Earth and the hypothetical 8 billion or planet X. Technology and knowledge of a civilization only 1,000 years ahead of us could be as shocking to us as our world to be to a medieval person. A civilization 1 million years ahead of us might be as incomprehensible to us as a human culture is to chimpanzees. The planet X is 3.4 billion years ahead of us. There is something called a Kardashev scale, which tells us to group intelligent civilizations into three broad categories with the amount of energy they use. Type 1 civilization has the ability to use all the energy in their planet. We're not quite type 1 civilization, but we're close. Carl Sagan created a formula for the scale that puts us at a type 0.7 civilization. A type 2 civilization can harness all the energy of their host star. Our feeble type 1 brains can hardly imagine how someone would do this, but we tried our best, imagining things like Dyson spheres. A type 3 civilization blows the other two away, accessing power comparable to the entire Milky Way galaxy. If this level advancement sounds hard to believe, remember planet X is above their 3.4 billion years for their development. Let's compare planet X if they developed like humans. If a civilization on planet X were similar to ours, we were able to survive all the way to type 3 level. The natural thought that they would probably had mastered interstellar travel by now, possibly even colonizing the entire galaxy. One hypothesis as how galactic colonization could happen is creating machinery that can travel to other planets, spend 500 years so self-replicating and using the raw materials on their new planet, and send the two replicas off to do the same thing. Even without traveling anywhere near light speed, the process would colonize the whole galaxy in 3.75 million years, a relative blink of an eye when we're talking about scales of billions of years. If you continue speculating, if 1% of intelligent life survives long enough to become a potentially galaxy colonizing type 3 civilization, our calculations above suggest that there should be at least 110,000 type 3 civilizations in our galaxy alone. And given the power of such civilization, their presence would likely be pretty noticeable. And yet we see nothing, hear nothing, and we are visited by no one. So where is everybody?